Good afternoon, everyone. I'm Pete Robertson. Thank you, Jeremy, for the introduction. I am a solutions architect with AWS up here in Huntsville, and glad to be with you today. I'm not going to spend a lot of time giving an introduction to myself. I've been in IT for my entire career in a variety of roles, but really when it comes to today's topic about running VMware in AWS, my first exposure to virtualization was all the way back when I was still in college doing some research projects, and I stumbled across the concept of virtualization in the early 2000s, and it was fantastic for me. I didn't have to manage so many pieces of hardware, right? I could run multiple different systems on a single box. And so I trust most people are familiar with virtualization. I think it's become, obviously it's the normative way that we run compute services today in the industry. But really just allowing us to take a piece of hardware and abstract its capabilities out so that we can run multiple independent operating systems on top of a single piece of hardware. And no longer are we kind of dependent on burnt-in identities that would be there if we didn't have that abstraction layer or hypervisor. So I think a lot of people are used to it on a personal level. You may run things like VirtualBox or Parallels or VMware Fusion or Workstation on your laptop or desktop for you to be able to run multiple systems and not do the kind of old approach of dual booting a piece of hardware. But you may not all be familiar with VMware. So let me just quickly summarize that. So VMware takes this concept of virtualization and makes it enterprise scale and enterprise ready for organizations to use virtualization across the data center. And they are by far the predominant market shareholder. 92% of organizations run VMware. So it is pervasive. In fact, you probably find that a lot of the systems you interact with in your day-to-day jobs with your employer are running on virtual servers without you even realizing. And there's a lot of benefits for doing that. So, when I talk to customers about, how do they operate in the cloud, most of them, are coming from an on-premises environment where they have hundreds or even thousands of systems, most of which are typically virtualized. And again, due to the predominant market share of VMware, that's a VMware shop running VMware virtual machines. So I have customers that are doing various different cloud projects with AWS that are asking things like, well, how do I move these existing systems, right? It might not be a project where we're doing a complete rebuild, transformation, modernization, but I have workloads that I want to lift and shift and move to AWS that are VMware virtual machines today. How do I do that, right? And there's a number of different approaches to doing this, right? You can certainly take tooling that we provide and other third parties provide to take a virtual machine and convert it over and run it, for example, as a native EC2 instance, right? Obviously, EC2 from AWS is virtualization. We're running an EC2 hypervisor, and EC2 instance is a virtual machine running in AWS's global infrastructure. But that also, depending on the use case, which I'll get to in a minute, poses some potential challenges because we're now converting to EC2, and that may not be something that the customer is looking to do. I have many customers that say, I don't necessarily want to do that. I want to run VMware virtual machines in AWS. I want to keep managing the way that I manage them today. And so there's definitely a number of use cases where we have customers that want to do that. They want to take a VMware virtual machine and run it in AWS. So, when I say there's use cases, kind of what things are we talking about? So let me give you a couple examples. So when we talk about why you would want to run VMware in AWS, we typically see one of these four use cases. The first is data center extension. Okay, so we saw a lot of this obviously with COVID, particularly when it came to things like VDI environments. Everyone's now not working on a workstation in an office. They're working from home, but instead of having a small pool of virtual desktops, we now need thousands of them. Well, how do we scale, right? Especially during COVID, where we can't buy more hardware for our data center quickly. But my VDI environment is based on VMware. I've got templates already built. I just want to rapidly scale. How do we do that? That would be a use case for running VMware on AWS. Disaster recovery is another one, right? I'm running on premises, but I want to be able to get away from maintaining a colo or data center facility for DR. So I want to instead be able to bring up very quickly in a disaster my workload in the cloud. And again, I don't necessarily want to compound the stress levels that I'm under during a DR event to where I now need to start interacting with that environment in a different way. I want to have the same tooling that I'm familiar with. So DR is a use case that we see. Cloud migrations, again, I know VMware, I just want to move it. I have the talent there, I want to do things quickly. So let's just do an application or a data center wide migration of what I have today to the cloud. And let's do that very quickly. And the last one's really interesting, right? The last one is around next generation apps. And we see a lot of customers that are really looking at this as a use case because they want to start to take monolithic applications, or they want to start to leverage native services and refactor applications. But those applications today comprise of, tens or hundreds of virtual machines that together make that application suite. So I want to start taking it apart slowly. That's a long-term initiative, not something we do in a couple of days or a couple of weeks. But as I start to refactor the application, I don't necessarily want, or I can't, due to performance reasons, have parts of the application running on premises and parts of them now as native services in the cloud, because it just won't perform correctly with the WAN connection in between. So if we can run the entire application suite locally in AWS, and now start to integrate as I modernize AWS services, but everything is local, then I have optimal performance, I have flexibility, it doesn't impact my user experience, and yet now I have the ability to continue to modernize. So these are the use cases. Now, I am not going to speak today on any kind of sales pitch or marketing. I really want to dive in and explain how we solve this problem. And we solve this problem with a solution called VMware Cloud on AWS. And I'm really going to go through and explain that for most of the time here today. I do have on the call with me one of my peers. His name is Drew Rutledge. He is a specialist on VMware Cloud and AWS. So we really do encourage questions throughout this. So as they come up, please feel free to come off mute and ask a question. We'll certainly take them at the end as well. But I'm confident that between the two of us, we'll be able to handle almost anything that you can ask us today. And if not, we'll follow up with an answer. So VMware Cloud on AWS, what is it? Okay. Well, customers are typically familiar with having their on-premises data center. And again, if that's running VMware, they would be familiar with something known as vCenter. That is the management plane or management appliance for a data center-wide VMware deployment. It's where they can also write scripts and integrate with APIs. But if we're going to start running VMware on AWS, what exactly does that look like? So this is a solution that has been jointly engineered between VMware and AWS. Okay, it is a partnered engineered solution. It's also a managed service. Okay, so I'm going to go in today to kind of show you what's going under the hood, explain the technology, partly because I find it fascinating, and I'm sure you will too. But I want you to understand that this is delivered as a service. So if you are running VMware on premises today, you're used to managing servers and storage and racking equipment and installing hypervisors and maintaining patches. All of that goes away with this. All you will need to do with VMware Cloud on AWS is log in as an administrator and manage your virtual machines through vCenter. You don't need to worry about anything from the hypervisor down. That is delivered to you as a managed service. So bear that in mind. I'm going to show you what's going on under the hood, but the complexity is taken away because it's delivered as a managed service. So how do we do this? Well, first of all, we start with AWS's global infrastructure. I'm taking it for granted here on this being an AWS user group that everyone is familiar with that. I'm talking about regions and availability zones, etc. And then we're going to build this solution on top of it. Okay, so we're going to be leveraging our physical facilities, EC2 hardware, and I'll cover that more. Okay, this is not nested virtualization. We're going to be putting VMware on top of bare metal EC2 hardware. And then we're going to be running several components of the VMware software portfolio. And that's what you see on the screen right here. So there's really three core VMware technologies. There's vSphere, and that's usually when most people say VMware generically, that's what they're referring to. So that is the hypervisor along with their management software to manage virtual machines running on their hypervisor. Then there's also a solution known as vSAN, okay? That's virtual storage. And then NSX, which is VMware's network virtualization and security solution. So together, these three components are referred to as what is known as an SDDC, or a software-defined data center. What we're doing here is we're leveraging these three together. It's really the concept of hyperconvergence. So if you're not familiar with that, a lot of legacy environments use three-tier architectures. So you have your server platform that provides compute capabilities. You have a different platform, different solution, different piece of hardware that provides storage. You know, you've got networking or SAN connecting everything together, and you're managing it as several different solutions that together provide you the overall capabilities to run your data center. In hyperconvergence, we take a node, a server that has obviously memory and CPU capabilities. It also has local disks, and we leverage those. So if we want to scale out for performance or capacity, we just add more nodes, and we scale up either because we need more capacity or we want greater performance or throughput. And so we're leveraging that piece of hardware with these three pieces of software layered on top to give us control over the compute resources, storage resources, and network capabilities of that piece of hardware, and then we scale out. So as we want to scale out an SDDC cluster here, we add more bare metal EC2 instances to the cluster, and you'll see that as we go on. So you can notice here that we're running vCenter, the management plane, in AWS. So we have the same management plane now on premises as in the cloud. So it's very familiar to organizations from an operational perspective, and we can actually link those together with something known as hybrid link mode. So now you have a single pane of glass to actually be able to manage virtual machine workloads irrespective of where they're running, whether it's in your data center or in AWS using VMware Cloud. And then that means, because we have that same consistent layer, that anything that you have as far as automation, anything that leverages that vCenter API, you can see it says vRealize here on the screen. That's a kind of set of operational tooling that VMware provides. You can use that. So if you've written playbooks on premises, they will also continue to function against workloads running in the cloud. So that gives you that seamless, consistent experience. Now, how do we integrate this with native services? Because again, that's why customers are looking at public cloud, is because of the flexibility and agility the native services give them. Well, the NSX Network Layer now allows us to integrate those at extremely high throughput and extremely low latency. So you can start to build architectures and applications that leverage both, leverage VMs and native services. So that is, at a high level, what VMware Cloud on AWS is. So I'm going to kind of go through now under the hood, the components. So as I alluded to, we're running bare metal EC2 instances. Okay, so not virtual instances. A physical piece of Amazon EC2 hardware is being leveraged to deploy this solution into your SDDC. Now, the way this works, obviously the white box here is the global infrastructure in a region. Because this is a managed service, the account and the VPC into which this is deployed is actually owned and operated by VMware, since it is a managed service. And I'll cover in a minute how, therefore, you get to run workloads on it and yet still connect to and leverage resources in your own AWS accounts. But as you can see here, EC2 bare metal instances, I'm showing three, these little orange boxes here. And we run the software stack on top. We pool those resources together to build you an SDDC cluster. So from a compute perspective, you can have two different types of EC2 nodes, an i3 metal or an i3EN metal. Okay, there's a lot of specs on the screen here. There's differences in the CPU generation and family, differences in their clock speed, number of cores, etc. The really big one to notice is the difference in the amount of storage, because again, we're taking the total storage across the disks that are locally in that piece of hardware, and we're taking that and pooling it together to provide the storage and performance capacity for you to run your virtual machines. So the EN, the one on the right here, as you can see, has nearly 45 terabytes of raw storage in it because it's made up of 7.5 terabyte NVMe disks. The one on the left has a much smaller capacity. So there are some other differences. So you get basically to choose based on your requirements and performance and capacity as to which type of node that you would use. But once you've built your cluster, as you scale your cluster up or down, and I'll cover that because we still get elasticity here, and that's one of the use cases, right? You might have a disaster recovery site. You just want a couple nodes to be able to ingest data that's being replicated. But if we start to fail over and recover, we want to scale up this cluster and add more nodes to provide sufficient CPU and memory. That's a very common use case. I don't have to pay and run a cluster that's sitting there warm for peak capacity if I don't need to. We can add additional nodes into this cluster in about 12 minutes. So we can be very elastic in scaling up and scaling down. So we're taking that data and pooling it to create the storage layer. So that's what we see here. Okay, so what you'll notice is we're combining multiple services here, VMware technology and AWS technology. So we've got the EC2 hardware for the compute node. We're actually booting those devices using EBS. So Elastic Block Store is the boot volume for those nodes to be able to boot them up, have ESXi load up as the hypervisor. You can see here we've got the kind of the disk configuration in them. And what we do is we take some of the disks, okay, and we leverage that for a caching tier in vSAN for performance reasons. And then we take the rest of the space to create your capacity tier. And vSAN is optimized to make sure, one, that we're putting the data as we write it to disk across multiple disks, across multiple nodes to make sure that we have resiliency and high availability, but also to do it in a way that optimizes performance. So this is what it looks like. Once we've pooled all those disks together, we create a management data store. From a VMware perspective, you'd be used to dealing with data stores. And that management data store is where all of the management appliances reside. Okay, so there are virtual appliances that will run in your cluster that are deployed and managed by VMware as part of this managed service, such as vCenter. Okay, there's also going to be virtual machines in there to facilitate things like replication and the networking with NSX. And then the rest of that is dedicated to you as your workload data store. And there, this is where you, as the cloud admin, you have control over deploying or replicating virtual machines into the workload data store. All right, so let's talk about networking a little bit, because for most of the customers that we work with, they already have virtual machines with VMware on premises, and therefore we're creating a hybrid environment. We want to have a steady state or a fairly lengthy migration plan where we're going to have resources running on-prem as well as running in VMware Cloud on AWS. So how do we do that networking? And as I said, from a VMware Cloud on AWS perspective, we're using VMware's NSX as the network virtualization layer here. So how does that work? Well, on the left here, you can see I'm representing the customer's data center. You've got your systems running here today. And I'm hoping, if everyone is following best practices, that we have a firewall in place on the edge of your environment. And then you probably have some form of device capable of doing routing at your edge of your network. Over on the AWS side, we have the VMware Cloud on AWS SDC, and deployed into your cluster of hosts is going to be a virtual appliance that is known as the NSX Edge appliance. It performs many functions, but one of them is to run something known as the T0 router. So it is a virtual router, and we leverage that for terminating things like IPsec tunnels and to do BGP peering for your network engineers that want to do routing. So inside the SDDC, we break the network into two different pieces. So we have a management network, and that's fully controlled by VMware as part of their service. And things like vCenter and all the necessary management components reside on those virtual network segments behind their own secondary router known as the management gateway. You will have another one called a compute gateway. In NSX speak, it's a T1 router. and you then get to define your virtual networks. Now, everything here is network virtualization. So we're not going in and creating, subnets in VPCs and associating them with availability zones like you would normally do. That's there under the hood, but that's taken care of as part of the managed service. When you're defining a network segment to which to attach your virtual machines, it's encapsulated in a protocol known as Geneve, which is part of NSX. It's like VXLAN with some additional extensions. And you will attach your virtual machines to logical network segments, as you can see here. And that's all part of what NSX does. Gives you a lot of capabilities as well, like micro-segmentation. That's why you see these little firewall icons here, because we can write distributed firewall policies. It's a little bit like having a security group in native AWS to where you're enforcing a policy on an individual ENI. Here it's enforcing policy on what's known as a virtual NIC attached to a VM. So how do we connect the two environments? Well, we can use services like Direct Connect, okay, or VPN. We have the option of doing either. If we're doing the VPN, whether it's over the internet or whether we do VPN as an IPsec tunnel over Direct Connect for encryption, in both cases, they will terminate onto the NSX edge router. So when you have an SDDC environment, you will have a separate console. You go to vmc.vmware.com, and in there you will have capabilities to specify things like what is your IP of your on-premises appliance, and then that console is going to orchestrate not only the VMware components, but any changes to the underlying AWS components to facilitate that tunnel going all the way through to NSX. You see, obviously we have a virtual gateway there. We're not using it. But we're terminating the tunnel to the NSX edge T0. So we've got connectivity to on-premises. And I'll talk more about this because one of the use cases is I want to be able to move virtual machines to the cloud, but I don't want to have to turn them off to do it. Okay, so VMware has a solution known as vMotion. It's used all the time within a data center. So you may not realize this, but you might be connected to a virtual server. You might be interacting with an application that is on a VM. That virtual machine can be moving between different physical servers in that data center while you're using it without you even realizing. And that's called vMotion. It might be done to optimize performance and balance the load across all the physical servers. It might be because your operations team is doing maintenance. It might be in result to an event that is unplanned, but that capability is known as vMotion, moving a virtual machine while it is live from one compute server to another. And we can do that from your data center to AWS without users even being disconnected. And we'll explain how to do that in a minute. All right, so moving on. This is really where we get even further under the hood. So this is how we provide connectivity out of the environment and also how we provide connectivity into your AWS account. So here on the left, the green box represents the VPC of the SDDC or your cluster that's managed by VMware. And here you can see we have 4 EC2 bare metal hosts that are comprising that cluster. Each of them has an ENI that is attached over and mapped to a subnet in your customer-owned VPC. Okay, so the EC2 host is in the VMware account, the ENI is in yours. And these are mapped through to every single host that you have in your cluster. We actually reserve a certain number of addresses in your subnet so that you can scale the cluster as well. But what happens here is this. That NSX Edge VM that I told you about that provides the routing capability, well, it's only ever active on one of the hosts in the cluster. So here you can see that it's active on host 1, which means that over here on the right-hand side, your VPC route table for the subnets that are used for virtual machines in your SDDC, your virtual machines in the VMware Cloud cluster, the route table for those subnets points to the ENI that is currently active for that NSX router. So if a host fails, we immediately fail over the NSX edge to one of the other hosts. And at the same time, we update the route table to point to what is now the new active ENI. So traffic is going to go through the host that has the NSX Edge active between your account, your VPC, and the VMware Cloud SDDC. And this is how we get communication between native services and what you have running in VMware. So here I'm just kind of illustrating what happens if that link fails. It moves down, and now you can see the route tables updated to point to that new ENI. Okay, so I talked earlier about you still get elasticity with this, right? That's one of the main benefits of going to the cloud is the elasticity. Well, how do we do that? Okay, if I'm now running VMware vSphere on top of EC2, do I get that elasticity? And the answer is yes. And we also have something known as elastic DRS, or distributed resource scheduler. And this can be as simple as you set thresholds to automatically determine when to add or remove an additional EC2 host into your cluster. Okay, and there's different policies depending on how aggressive you want to be in adding and removing. But again, when you either manually decide or automation decides to add a new host, it takes between 12 and 15 minutes to take one that's there in an Amazon data center, provision it, install ESX, get it configured for your account, and add it to your cluster. And we take that same automation approach in how we provide high availability. So how do we handle failures? Okay, so if we have one of the hosts in your cluster start to have any kind of failure, right? So it might be the host is completely failed, or maybe a disk in there has failed. And a disk failure is still problematic because remember, we're taking the capacity and performance of those disks and pooling it in vSAN. Well, we want to remediate that for you. Okay, now typically if you're doing this on premises, you're going to hopefully get some alert through SNMP or something else. And one of your admins is going to run into the data center and switch a disk or pull a server. That's not a fast process. Here, because we have EC2 compute resources available in capacity in our facilities, the automated process starts. We add in a new host to the cluster first, and then we either replicate or recreate the data. Okay, we've kind of got like RAID-like capabilities in vSAN. So if the host is completely failed, we put a new one in and we start rebuilding the additional copies of the data on that host to make sure we maintain sufficient copies of each block of data to make sure that we maintain the redundancy levels that you have set in your policy. So again, automated process for handling failures. All right. I don't know if anyone noticed this, but in the diagram I showed you earlier, it was a cluster deployed into a single availability zone. Now, obviously our availability zones are fairly resilient. They're made, backed by one or more AWS data centers, but we always recommend best practices are to deploy architectures that are multi-AZ. So how do we do that here? Well, now we introduce the concept of a stretched cluster. And what that involves here is we have EC2 bare metal hosts in 2 availability zones. And we basically are still doing the same thing. We're still pooling the capabilities of those hosts to create a single storage layer. We're stretching the networks across them. So from a virtual machine perspective using NSX, I can have the same subnet now spanning 2 availability zones because of that virtual network layer. So I now take resources in 2 availability zones and put it into one pool. If I had a total failure of an availability zone, I have enough capacity and I have the data already residing in the other availability zone that the built-in high availability constructs of VMware would restart any virtual machines that went down due to an availability zone failure automatically on the hosts in the other availability zone. And their data was already existing there. We don't need to re-IP them because that network is stretched. Everything will come up in basically the time it takes to detect the failure and reboot the virtual machine. So very, very fast. Now, since we're also using the very fast network that we have between availability zones in our regions, we're doing synchronous writes of data. So as your virtual machines are writing to disk, that data is being committed to disks on hosts in both availability zones so that we have synchronous writes, a 0 RPO as far as high availability is concerned. And that is how we do a stretched cluster. Now, we also do offer, because I know as soon as we say multi-AZ, people start thinking about the fact that, well, hang on a second, cross-AZ usually incurs additional charges. That is true, but for any cross-AZ traffic that is within the SDDC, you get a certain amount free every single month. So we're dramatically minimizing the cost impact of doing a multi-AZ environment. All right, so that really is an overview of VMware Cloud on AWS. I'm going to jump through two more things. How do we now build architectures that leverage native services, and how does that work? And how do we also then get your virtual machines from on-premises or from somewhere else into VMware Cloud on AWS? And I mentioned earlier, kind of as a teaser, yes, we can do that without turning the virtual machine off. So I will cover that now. So integration with native services. Okay, so here on the left, again, this is the VMware Cloud account, VMware's managed VPC, and your cluster that they're managing, that you have access to the management plane for managing your virtual machines. And again, we said that from a network connectivity perspective, traffic from these VMs goes through that NSX edge router across that ENI and into your account. And so if we had RDS instances, Redshift, anything, other EC2 instances, anything that has an endpoint that can be attached into a VPC, we can route to it across here at very high throughput, very low latency. So now I can start to build, for example, an application layer that's comprising virtual machines, but I'm now using RDS. And this is a really common use case, right? We have people that are saying, I have a lot of virtual machines that talk to my on-prem Oracle database today. I'm looking at moving away from Oracle. I'm considering things like RDS, or I'm looking at things like Aurora. But I want to focus my efforts on that database data strategy project. I don't want to have to think at the same time and increase the scope of the project about how I also have to rewrite all of my applications. So let's not do that. Let's move those virtual machines to VMware Cloud on AWS so they still have locality to the database. And now we can have the backend database upgraded to be RDS, Aurora, whatever it may be. And yet the VMs remain intact as is. So that's an example of how we're integrating services there. Well, let's think about a broader use case. How about I'm building like a web application where I have users on the public internet? How do I stitch everything together in that type of scenario? So here on the left, I have a user out on the internet. They're coming in, and now we start to leverage, the kind of native services that we like to use in AWS. So I'm going to go through AWS Web Application Firewall. Coming in, obviously, I have to have an internet gateway to be able to have a application load balancer with a public IP assigned, an elastic IP. But if you notice here now, behind the load balancer, the target compute are IP addresses that are virtual machines running over here in VMware Cloud on AWS. So the difference here again is to get to them, I'm going through that ENI, the VPC route table over here on the left is going to say to get to the 172.31.1 subnet, go to this ENI, and that will take me to NSX, which will then forward my requests on to these virtual machines. So there's tremendous flexibility in how we can build architectures that combine both native AWS components and VMware virtual machines and allow you to adopt these different types of architectures. Again, a lot of times it's for the use cases I said at the beginning. I want to be able to accelerate my cloud journey. I want to be able to focus on small components of that innovation. How do I do that? I don't want to boil the ocean and try and refactor my entire data center in one go. This is a solution that allows you to start to focus on the low-hanging fruit and start to modernize while maintaining consistent operations of what you're familiar with today. All right, so how do we get stuff there? Okay, there is a service called VMware Hybrid Cloud Extension, or HCX. It's included with the licensing. It is, again, it's pay-as-you-go pricing, just like everything is with the cloud. There are obviously options like there are with reserved instances to pay for a certain commitment upfront for additional cost savings. But included in however you decide to consume VMware Cloud on AWS. There's no like additional upcharges here to use HCX. It's included with every approach to consuming VMware Cloud, pay as you go or longer term commitments. And HCX is included for free, and it's a service that allows us to migrate VMs to VMware Cloud on AWS with a lot of flexibility. So the way it works, here on the left, I'm showing a customer data center or cloud, okay? Because this isn't just for doing on-premises VMware migrations to VMware Cloud on AWS. It could be that you're doing migrations from another VMware Cloud on AWS, SDDC in a different region. It could be that you have workloads running in a different cloud. It's really the source environment. Okay, so on the left, we have the source, and on the right, we have the destination, which is VMware Cloud on AWS. So HCX, first of all, is going to build a site pairing. So it's going to set these two sites up as paired. It's going to start to get information about inventory and specific settings. And it's going to, essentially make sure that we are aware of configurations on either side. It's also then going to provide an interconnection at a network layer. Okay. And this is so that we can do data replication. So built in to HCX, you can actually deploy some virtual machines. The OVAs are provided as part of the service, so you could deploy these into your on-premises environment, and they facilitate additional capabilities. So one is it will do data replication from your source environment agnostic to your storage. So as you can see here, it doesn't matter if I'm not using vSAN on premises. I could be doing a traditional fiber channel or iSCSI SAN. I could be doing local disks, doesn't matter, okay? Agnostic to the storage on premises, I'm going to have an appliance on-prem that is going to allow me to replicate the underlying storage of my virtual machines on premises to vSAN running in VMware Cloud on AWS. Similarly, I'm agnostic to the network. So it doesn't matter if I'm doing traditional networking, if I'm doing some advanced virtualization. This one at the bottom here is a kind of Cisco virtual solution. NSXT and NSXV are different versions of VMware's network virtualization suite. Doesn't matter, we're agnostic to that again. I will put an appliance on premises that will then stretch my networks at layer 2 into VMware Cloud on AWS and into an NSX segment that we create over here. So I now have a stretched network, a stretched subnet from on-premises to the cloud. That's key to allowing us to do a live vMotion, because obviously if I have to change the IP address of a system as it moves, well, that's a disruptive change. If I can keep its network identity the same, keep its IP address the same, and move it, I can now do it to where even though one is on premises and one is in the cloud, that same technology that VMware had around doing live migrations from one compute platform to another still works here. So I can move it from on-prem to the cloud without it going down. That's an option, okay? But there's different options, okay? And again, we can leverage direct connect for this, or we can use just an internet connection, okay? If we use the internet, we're doing everything with encryption, right? We're encrypting everything in transit. And we also provide WAN optimization. So the appliances that you deploy on premises to facilitate this also have WAN optimization algorithms. So you can do live migrations with internet connections as low as 100 meg throughput and with some pretty high latencies and still do live migrations. So let's look at the migration methods, okay? Cold migration, so that's easy. That's just a file copy and turn it back on when it gets there. It's very easy if we want to do things, without considerations for downtime. But most customers don't like that approach unless it's for kind of tertiary systems. So how do we accelerate this and make it faster? And there's really two approaches. So I said vMotion. So that's a no downtime migration from on-premises to the cloud. Does require that layer 2 network extension. There's bulk migration. Now, bulk migration is fantastic if you don't mind having a small interruption to virtual machine connectivity. You can actually schedule up to 200 virtual machines to be moved together as a move group. Replication will take place behind the scenes. It will get it in sync, and then at a scheduled time that you can set, it will then essentially take down the source virtual machine and bring it up on the destination in VMware Cloud on AWS. So just basically the time it takes to shut down and power on is the interruption window, and then everything is now moved over and operating in the cloud. And that gives you some other flexibility in making some changes during that process if you wanted to. Replication assisted vMotion is just another option that again allows us to combine vMotion with some of the capabilities of bulk migration. That's another no downtime method. And then there's actually one last one, which is an OS assisted migration. So if you're wanting to take something that is not a VMware virtual machine, but move it and convert it to a VMware virtual machine in the process, then you can actually put an agent into the operating system of that source machine, and it will replicate and convert a VM to be an exact image. So it's kind of like a P to V or V to V of that system. All right, I know I've covered a lot, so let me summarize here. VMware Cloud on AWS, okay? It is the preferred solution for running VMware workloads. And when I say VMware workloads, I'm meaning VMware virtual machines, not something that's being converted to something else. So actually still maintaining it as a VMware virtual machine managed using the VMware management tools. It gives you the same infrastructure and services as you're accustomed to on premises, as in the cloud. So you have consistency of operations, your talent is already skilled, and you can move extremely quickly. It's built, as we said, on top of AWS's global infrastructure and leveraging things like VPCs and EC2. Encryption is there throughout. So obviously security at AWS is job zero. So we have encryption at rest by default. So the vSAN layer in VMware Cloud on AWS uses encryption. KMS is managing the keys. Okay, so you can't provide a customer provided key for this because it's a managed service, but you still get control over key rotation and things like that. And then obviously the different technologies like NSX and IPsec and HCX provide encryption in transit for the different components of the overall infrastructure. And now we can run VMware virtual machines on AWS in a consistent manner, locally, and able to interact very, very quickly at low latency and with high throughput with all of the native services that we love to bring to market for our customers. So that was a lot, I know. Happy to take any questions. Jeremy, I don't know if any were submitted in chat while I was presenting, but happy to take any questions at this point.